Okay, this is geometry, and we are going to review lesson 13. So we're about to begin lesson 14, and we want to go back and remember, before we get into reflections, what's a rotation? So we're going to take a few moments here and review what it was, some of the construction techniques that we employed to be able to rotate objects, whether it be about a point that was shared by the rotated figure or a point that is not shared. So let's start with the first concept, which was what you were going to be able to do having finished this lesson. And again, this is a review of lesson 13 and the concept of rotations. Students, you should be able to manipulate rotations by each of the parameters of the center of rotation, the angle of rotation, and a point under the rotation. And so given the fact that we're rotating, we also want to have some terminology. Up on the screen, you'll notice that we remember that counterclockwise is just as it says, it's going in the opposite direction. And then clockwise is going in the direction that we would normally see a clock turn. And sometimes you'll see the abbreviation counterclockwise and clockwise. You'll see CCW for counterclockwise and CW for, not a very good C, but that's all right. CW for clockwise, okay? All right, so let's take a look. So in this figure, and this is one that you would have seen before, in this figure, you're rotating. Generally, the dotted figure, the one that's in the dotted, is the one that is the new one. And so we label that as A prime, B prime, C prime, and D prime. The original figure is labeled A, B, C, D. And so what you're really doing is you're taking a protractor and you're identifying points that are the same interest. In other words, we're going to identify that this point here and this point here. And we're going to use a protractor to measure the degrees at which it moves from here to there. And so sometimes you'll see a line. Some people might construct a line here and a line here, and then they'll overlay the protractor to determine the number of degrees that that point's moving. And you really only need, in order to determine the rotation angle, you only need to do one set of points. In this case, A to A prime. You should be getting the same rotation if you went B to B prime, C to C prime, and of course, D is the center of rotation. So in this particular problem, the center of rotation is the shared point of D. In this particular example, notice that we're rotating from, again, A, B, C, D, same figure, except we're not sharing that point of rotation. So in this particular case, we have to be able to find that, that point of rotation. And so how is it that we find that? That's the question that I want you to answer. So pause the video and I want you to go back and research. How do we find, how does the book find? In fact, later on, we actually talk about how to find this. However, in this particular problem, they give it to us. So they give us E, but we should be able to find that letter, and we'll talk about that later. But be thinking, how is it that we could find E if we don't know it? So, having said that, you'll notice once again, you could take A and A prime, and you could once again set your protractor, and you could draw a line here and draw a line there, and measure what the rotation angle is. You'll also notice that we could write 60 degrees or 300 degrees clockwise, or -3 degrees. 300 rather, sorry. So there's a number of different ways we can answer this depending on how we look at it. Okay? All right, we'll come back to this one again in class and talk more about this, but this is review. We've seen this problem. We've done this problem before. Okay, and here's the answer to that question. How is it that we rotate M to the dotted line M and find that point of rotation? Well, it actually turns out that we're dealing with perpendicular bisectors. And we're also dealing with lines that intersect. So you will see that in this case, they constructed from A to A prime, a line, and B to B prime, a line. And then in green, they've constructed the perpendicular bisector of each of these. And that intersection of those two perpendicular bisectors, that's your point of rotation. And so the question I asked earlier, well, if they don't give you that point of rotation, you can certainly construct it by using your skills of constructing perpendicular bisectors. Again, connect A to A prime, connect B to B prime, and in two separate cases, construct the perpendicular bisectors. Where those two perpendicular bisectors intersect is your point of rotation. Here's a problem that you're told to find the center of rotation and the angle of rotation. And so in this one, we're combining, they give you two figures. You're to find the center of rotation first, and from there, you can also then navigate towards finding the angle of rotation. So number 4 is given to you as the answer. What I want you to do now as a form of review is to take the problem below it. Analyze this problem, kind of review this problem right here, how they get the answers, how are they finding this point right here? That's the point of rotation. So the center of rotation is right here. Again, review, how do they find that? How are they finding the angles of rotation? The answer's here. How are they finding that? And then what I want you to do is, as a way to review, do the same thing for this particular problem right here. And in class, we'll come back and see where we're at. All right, that's a good review of lesson 13. Keep in mind that rotations, as it says there, a rotation carries segments onto segments of equal length, and also a rotation carries angles onto angles of equal measure. In other words, the figure doesn't change, it's just positioning changes. All right,